You are welcome to Bamaina math class. In this video, we are going to see solution of second order differential equations. We have seen how to create differential equations previously by eliminating arbitrary constants. So in this case, we are going to see how to solve the differential equations created. So here is the root of the auxiliary equation. When a differential equation is given to you, a second order differential equation, you always uh, convert it into auxiliary equation, which is usually in form of quadratic equation, that is ax squared plus bx plus c. And we all know that a quadratic equation have two roots, or it normally has two solutions. So here is the root of the auxiliary equation. We have case 1, case 2, and case 3. And in each case, we have the general solution of the differential equation. So now, in case 1, if the root of this auxiliary equation, if the two roots obtained are real and distinct, that is, real and distinct root, that is, maybe you have m1 and m2. m1 is the first root and m2 is the second root. So the general solution of the differential equation is given as yg, that is general solution, is always equals to a exponential m1 then x plus b exponential m2x, where this a and b are arbitrary constants. And the second case is a case in which your roots are equal. That is, two equal roots. If in solving the quadratic equation formed, you obtain two equal roots, then definitely the solution or the general solution of the of the differential equation is given as yg equals to exponential mx into a plus bx, where m is the root, because in this case m1 is equals to m2, and all of them are the same thing as m. So this m is here, then a and b are arbitrary constants. Then we have case 3, which is the final case, in which you are going to obtain a conjugate root, or we call it imaginary root. That is imaginary root. That is, maybe you have alpha plus beta I, or alpha plus I beta, the same thing, or alpha plus I beta. This one and this one are the same thing. So in this case, it's a case in which the solution of the quadratic equation is imaginary root. So in this case, your general solution is yg equals to exponential alpha x, that is your alpha here, then into a cos beta x plus b sin beta x. So this is the general solution for imaginary root, that is non-real root or conjugate root. So these are the three cases, and we are going to see an example here. So for example, they said find the general solution of the differential equation, that is y prime prime minus 6y prime plus 9y equals to 0. So we begin by saying solution. So in this case, we take the auxiliary equation. The auxiliary equation is this one, y prime prime is the same thing as m square. Then minus this 6 is there. Then y prime is the same thing as m, because this one is double prime, that is why we take square. Then this one is single prime, that is why we set power 1. Then plus, this is 9, and we don't have y prime here, which means it is y prime power 0. Anything power 0 is 1. 1 multiplied by 9 is 9. So this is equals to 0. So this is our auxiliary equation, which is clearly a quadratic equation. So now we proceed to solve this quadratic equation. So we are going to look for two numbers, when multiplied to give us 9, when added to give us -6. Normal solution of quadratic equation using factorization method. So in this case, the two numbers are -3 and -3. -3 and -3. The factors. Our factors now are -3 and -3, because -3 multiplied by -3 is going to give you +9. Then -3 will give you -6. So you open two brackets, then you equate with 0, then you are dealing with m. So you write m here, then the two factors -3 and -3. So from there, you know either first bracket is equals to 0 or second bracket equals to 0. So in this case, it means m -3 equals to 0, or the second bracket m -3 equals to 0. This means our m is equals to, you take -3 to the other side, it becomes +3, because 0 is nothing there. Or m equals to the same thing here, -3 to the other side, it becomes +3. So you see we have two equal roots. That is, m1 is equals to m2. All of them are the same thing as what? 3. So which case is this? Two equal roots. That is case 2, when you have two equal roots, where m1 is the same thing as m2, all of them are the same thing as m. So the solution is yg equals to exponential mx into a plus bx. So it means yg is equals to exponential mx into a plus bx. So that is yg equals to exponential, our m is 3, so we have exponential 3x into a plus bx. So this is a general solution of the given differential equation. Thank you.